Welcome to video 1 on special right triangles, presented by 3Math Guys. Visit our website at 3mathguys.com and subscribe. Alright, so let's take one of the most basic of all shapes, a square, and there's a pattern I want us to kind of discover together here about the side lengths and the diagonal of this. So let's start with a length that's really simple. Let's say this square is 1 unit long, and so since it's a square, this will also be 1, and we can figure out the length of this diagonal. Don't make the mistake of thinking that'll also be a 1. It's going to be a longer distance than the sides are. And so this is a square, so it's a right angle, and we can apply the Pythagorean theorem. So I can say a squared plus b squared equals c squared. In this case, I'll have a, b, and my hypotenuse is c. And that's what I'm looking for. So I'm just going to plug these in. 1 squared plus 1 squared is 2, equaling c squared. Take the square root of both sides, and you end up with c equaling square root 2. So I get square root 2 long. And you could make that a decimal, 1.41, but we're just going to keep it in radical form here. Okay, so that's simple enough. Took a little bit of work, but we were able to get it. Well, what if I had a different square? What if I had a square that was too long? Well, let's do the math. So a squared plus b squared should equal my hypotenuse of c squared. So I'm going to get 4 plus 4, which is 8. Same thing as we had over here. If I don't want c squared, I want c. I want the distance here. So I'm going to take the square root of both sides, and I end up with c equaling square root 8. So I have square root 8. Okay. You can keep going. Try this with 3. You'll get 3 squared plus 3 squared, right? And so I get 9 and 9, which is 18, gives me a final answer of square root 18. I'm not going to show every little step here. So I get square root 18. And there's a skill of simplifying square roots, simplifying radicals. And most of the time in math class it seems like, why are we doing that? And one of the advantages is if you simplify square roots, there's patterns you can notice sometimes. And so, this square root 8 can actually become the square root of 2 times the square root of 4, right? 2 times 4 is 8, so square root 2 times square root 4 is square root 8. And this square root 4 really simplifies down to a 2. So I've got 2 times square root 2. So I'm going to rewrite this as 2 square root 2. And I'm going to take this square root 18, and I'm going to simplify that. I could really think of this 18 as square root something times square root something. And can I think of a perfect square that would go in there? And you could say, well, 9 times 2. And square root of 9 simplifies down to 3. So I have 3 times the square root of 2. 3 square root 2. And at this point is when you can kind of notice, oh, I think I see a shortcut here. So when this is 1, I get 1 square root 2. And when this is 2, I get 2 square root 2's. And when this is a 3, I get 3 square root 2's. And so I'm not even going to do all the work. This is a nice shortcut. I can say 4 square root 2. And if this was a 5 and a 5, then I'd have 5 square root 2. Or if I had like 8.7 and 8.7, then I'd take 8.7 times square root 2. And so this shortcut makes the two triangles that this square got split into what we call a special right triangle, because it's got a useful pattern, and squares are a common shape, so this is going to come up a lot. All right, and so let's kind of formalize this pattern. Like if I had you can imagine where the rest of the square would be here, but we're just going to look at one triangle in here. So this is 90 degrees. This was a square, so that was 90 degrees. I only need half of that, which is 45 degrees. Same thing down here, 45 degrees. And so this is called a 45, 45, 90 special right triangle. And if I said I have a side length of 3 or 4 or whatever number, I can find this real easy. Well, what if I want it to be any number I want, like, and I'm just going to say x. Well, it's a square, it used to be, so this would be x. And if I want to find the hypotenuse of it, I just take that side length of x and I multiply it by square root 2. The ratio between these is to go from the side length to the diagonal, I'd have to go square root 2 times bigger. Okay, so, well, how would you turn this x into that? Well, you'd go times square root 2. So what would you do going the other way? What if I was given this number and I wanted to have that number? Well, I would divide by square root 2. Okay, same thing over here. And then these are going to be the same as each other. So let's try a couple examples. And it shouldn't throw you off if the triangle gets turned to face a different direction. It's the same pattern. It's a pattern that describes the ratios or relationship between the side length or the legs. If you thought of this as it used to be a square, these would be the side length. If you're talking about it as a right triangle, these are the legs, this is the hypotenuse. Okay, so there's my right angle, and I'm just going to tell you this is a 45-degree angle, 45. So let's say I had something like this. Like, let's say I had a length of 8, and so I had to figure out what's the value for x and what's the value for y. And we just follow our pattern. There's no calculating involved. We did a whole bunch of calculating, and when we did all that work, we found a pattern. So let's save time. That's the whole advantage of this. And we don't have to do the calculating anymore. We can just do just apply the pattern. And the pattern is that the legs will be the same as each other, so x is going to equal an 8 also. And to go from the leg length here to the hypotenuse, I just multiply by square root 2. So this y value is going to be 8 times the square root of 2, and that's my answer. We're just applying this pattern that we've discovered. Okay. All right. So let's look at another example here, and let's say that we know we know these two lengths are the same. And if those two are the same and this is a right angle, then it has to be half of a square. So this has to be a 45. Has to be a 45. And let's say this hypotenuse is 10 centimeters. So the question is, how long are these legs? And I can't quite do Pythagorean theorem as easily as I could just do this pattern. I have a shortcut, so I might as well use it. Well, what's the relationship? If I know the hypotenuse and I want the leg length, I'm going to divide by square root 2 to find that. Okay, so let's do that. If I want to know this number, I'm going to divide by square root 2. So what is 10 divided by square root 2? And you can't just leave your answer like that. You don't want to have a square root as your denominator, and so there's a little trick to kind of get rid of that. Like, for example, if if I took 5 times 1, I get 5. If I took 8 times 1, I get 8. If I take 10 divided by square root 2 times 1, I get 10 times square root 2. So there's a little trick. I'm going to do square root 2 over square root 2, because anything over itself is equal to 1. And by doing this, when I multiply these two fractions, I'm going to end up with 10 square root 2 when I multiply the numerators, and square root 2 times square root 2 is 2. So, and then this 10 and this 2 are going to reduce, and I'll end up with a 5 here. 5 times the square root of 2. So this length is 5 square root 2, which means this is going to be the same thing, 5 square root 2. And there's even a pattern going this way where you'll notice that this number, if I cut that in half and then times square root 2, that's even a shortcut that you can find. So just a quick overview, quick introduction to this pattern. You'll want to spend some time with it. That's how you're really going to get good and fast at it, is by applying it. Okay. All right. Thanks for watching.